Are you a civil engineer dreaming to master road construction projects? Ever wondered how projects move from a simple drawing to an actual road under your feet? Today I'm going to take you through a complete case study from project initiation, design, BOQs, contract, scheduling, all the way to site execution and progress reporting. Stay with me till the end because this is pure gold for any civil engineer serious about their career in road construction projects as planning engineer. Well, my name is Engineer Wakas Ahmed and I request you people to subscribe this channel so that in future I make any video relevant to your career and skills, you can find that video link on time. Phase 1. Initiation and documentation. Every successful road project begin with strong documentation. We first gather feasibility studies, geotechnical reports, traffic surveys, site investigations and municipality requirements. These documents from the foundation, if you miss them, you risk wrong decisions and delays. Always start right with full documentations. Phase 2. Design development. Next come the design stage, road alignments, cross-sectional drawings, pavement structural drawings, drainage system drawing, street lighting, layouts. Everything must be visualized and designed before a single machine enter the site. Good designs save time, money and future maintenance headaches. Phase 3. Estimation and BOQ development. Now, estimation time. We break down all scope into measurable quantities taken from the design. Earthwork like cut and fill, sub base and base layers, asphalt courses, concrete works for curbs and sidewalks, drainage lighting and marking. This is where your BOQ, your bill of quantity, is prepared with full clarity. Accuracy here means smoother execution later. Phase 4. Contract preparation. Contracts are the legal backbone. Tender documents, general and special conditions, technical specifications, and approved BOQs all come together. Always remember what's not written is not protected legally. Phase 5. Developing projects schedule with Primavera P6. Now the real planning engineering magic starts from here. We build a breakdown structure. We are going to divide our project into smaller and manageable components. WBS should include engineering and approvals, procurement of materials, construction phase, testing and commissioning, and final handover. We are going to divide our road construction project into different kind of sections on the basis of their chainage, like 0 plus 000 to 2 plus 00, to justify that this batch is going to present first section, second section, and then further on we are going to load it with site clearance, excavation, subgrade layer with FDD testing, sub base layer with CBR testing, base course layers, asphalt binder course, asphalt wearing course. Each layer must pass quality test before moving forward. So here we have road construction project within WBS, which is the first milestone of scope management. We are supposed to divide our project into smaller components. Our top level WBS is to divide road into four different sections. Let's say your project is 100 kilometer in length. We are going to give 25 kilometer each section length over here. Then further I can divide section 1 into this, and you can find there are different kind of, like earthwork is the sub component of section 1. Like all the things are gonna happen like earthwork, subgrade, cuttings, road site preparations, and within road works you can find here sub base, service space, pavement works, structures. Within structures you can find there are different kind of major structures, bridges, there are retaining walls, minor structures. In minor structure you can find cattle creep, box culvert, and likewise every other section will be downgraded or will be divided into further details. We will be adding up all the activities within Primavera P6 this window, and you can find here everything is loaded with the details. Like in earthwork there is clearing grubbing when you are going to prepare that site, natural ground compaction, excavation, removal of trees, granular backfill, formation of embankment, dumping of soil and sand as per the designer requirement, improved subgrade. After this layering or dumping with compaction is done, you are going to develop your sub base layering, aggregate base course, prime coat, asphalt concrete base course, tack coat. That is the vertical development of your road. That is the cross sectional drawing is going to give you the instructions how much thickness should be each layer carrying. And then you can see in further major structures there is a piling, there is abutment footing, you can see abutment walls, and further you can load all these things. These are the WBS of a certain bridge: piling, PLT, abutment footing, abutment walls, piers, transom, girders, diaphragm, curtain walls, wing walls, deck slab, and miscellaneous work. And then the same likewise another bridge is going on, and there are multiple bridges with this sample project. And if you want to have this real time, this case study, then you need to comment in this video so that our team can approach you and can provide you this XZR file and PDF file as well. So here you can find the different kind of minor structures: cattle creep, which is part of this road construction project, box culvert, and you have to mention that specific chainage on which location it is going to be built up, right? Erosion work, drainage, erosion, all of these scope of work is part of our road construction. Curbs and chutes, drainage pipes, ancillary works, distance markers, utility ducts, and then section 2 is going to start. Within that, I'm going to highlight one more thing. As a planning engineer, if you want to learn this skill set, you need to understand this is scope management. Scope management, what we need to deliver on site area. But in case I'm going to click on this activity details, you can find here there are different kind of tabs over here. Within these tabs, you can find relationship tab, which is going to present you on the other side of our bar chart area, in which you can find there are different kind of activities are linked up with each other. This is called developing logic. That is the core part of a planning engineer, to develop logic on your project schedule. So that is going to develop your critical paths method. So if I'm going to filter over here critical, and you can find what is the critical path method of your project. So that is how you can find the critical path, the float zero path, right? And that is very important to understand. This is going to define your project strategy. And if I can go here into the resources, these are the manpower, material, and machineries you require with total budgeted units or man hours to consume on this certain activity. This is going to develop your cost as well as your man hours, and that is how you are going to make your project cash flows, your resource requirement plans. Like this way, you see dozers, front end loader, vibrator, helper, and same way there are spreadsheets which are going to help you that how many man hours cost is required in your further look ahead plan. So this is how, as a planning engineer, you are going to gather all of that data, put that data, understand the process, load that data into Primavera P6, and generate project schedule, S curves, resource requirement material, and all those reporting documents which are mandatory required by client as per planning engineer job role. Critical activities and CPM logic. While doing these road construction projects, civil engineers, attention over here. Critical activities control your project timeline. Earthwork must finish before sub-base. Sub-base must complete before asphalt. Drainage and utility relocations must run in parallel without delays. Procurement of asphalt material and pipes is also critical. Float must be managed. Float is the amount of time an activity can be delayed without delaying project duration. So you need to understand and learn how to manage your float. So float is always the property of non-critical activities, whereas critical activities having zero float. And there is one more thing I'm going to convey over here. In job interviews, they are going to ask you what is the float limit in any project. So there is a thumb rule I'm going to share over here. Any project, the duration should be, the float should be 10 to 15% of total project duration. Now, procurement and resource management, the very integral part of civil engineers which you are going to become a planning engineer. Procurement drives construction. Delays in material delivery like asphalt, pipes, or any electrical or mechanical item which is important or integral part on your construction project should not be delayed. Heavy equipments like rollers, pavers, graders must be properly loaded into the plan as per your construction methodology. Risk management. Civil engineers, this is gonna be a very important part of our project scheduling. Risk, you must plan for material shortages, authority approval delays, design revisions, traffic divergence problems, land acquisitions, weather impacts on asphalt work. Always keep a risk register and prepare mitigation plans. Progress reporting and monitoring. Here come civil engineers. We as a planning engineer going to intimate, report to all the stakeholders that what is going on, what was planned and what we are achieving. During execution, daily, weekly and monthly reports are vital. You must show planned versus actual progress, milestones achieved progress, lab testing results, resource utilization, earned value management based progress report, delay analysis, and recovery scheduling. All these things are part of our ongoing tracking project reporting systems. And here I'm going to share with you people as a civil engineer, if you want to develop your job career as a planning engineer, then you need to learn these lesson learned from my experience. Late material delivery can kill your project flow. Poor quality control on earthwork leads to costly reworks. Authority approvals take longer than you expect. Plan buffers, add some marginal additional duration into your documentation approvals and all those activities. Always integrate civil and mechanical, electrical and plumbing activities tightly during underground works. Learn from the field. Every lesson you apply saves times, save cost and repetition as well. And now at the end, if you want to master road construction, project planning, scheduling, if you want to learn this complete skill set, you need to conquer these four skills. Project management oriented concepts in which you need to understand what is scope management, schedule management, procurement management, cost management, resource management, risk management, and you need to understand the road development, horizontal development, and vertical development, and then Primavera P6 as a tool, and contract documentation. All these four things are going to enable you to prepare your project schedules, cash flows, cost management sheets, material requirement sheets, look ahead plans, tracking, earned value management based methodologies, delays, analysis, EOT, and recovery schedules. My name is Engineer Vikas Ahmed. Once again, I would like to invite you people to enroll or to participate free of cost in my upcoming live webinars in which I'm going to train you a basic planning engineer skill set. And if you further want to master this skill set in professional way as per Gulf region or European industry, you can enroll in my full-fledged training. I hope you enjoyed this training. I would request you people to write in the comment area that how did this help you people in understanding project planning, scheduling from the perspective of a civil engineer and development in road construction projects.